Good afternoon, students. Today we are going to start a new topic, hypnotic and sedatives, part first. The first is a definition of sedatives. Sedatives are the agents which reduce anxiety and exerts calming effects. These are called as the sedative. Hypnotics. Hypnotics produce drowsiness and facilitates the onset and maintenance of the state of sleep. Effect of a dose dependent depressant effect on the CNS, which includes at a low dose the drugs acts as a sedative. If you increase the dose of that drug, which is used to reduce an anxiety, if you again dose increase the dose of that drug, this drug are used to treat the amnesia, and all of you know that the sedative in a high dose acts as an hypnotic agent. So sedatives, high dose, used as hypnotics, or hypnotics in a low dose, used as an sedatives. Further increase in a dose of these agents act as an anesthetic agent. Again, further increase in a dose, this drug acts as an or which produce the coma, and very high dose, a lethal dose, may causes death of the patient. So, advice is this drug should be taken under the supervision of a medicinal practitioner. The sedative hypnotics are classified under the following classes. The first class is the barbiturates, or also called as barbituric acid derivatives. These barbiturates or the barbituric acid derivative are classified under three subclasses depending on the duration of action. The first subclass of a barbituric acid derivative or barbiturates is long-acting barbiturates. The example of long-acting barbiturate is a phenobarbital. The second subclass of a barbiturates is a short-acting. The example of short-acting barbiturates is the butobarbital and the pentobarbital. Ultra short, that is third subclass of a barbituric acid derivative, is ultra short acting barbiturates. Example is a thiopentone and methohexytone sodium. The second class of sedative hypnotics is a benzodiazepine derivatives. Benzodiazepine derivatives are further classified into the three subclasses based on their action. The first subclass of a benzodiazepine is hypnotics. Hypnotics, the example of hypnotics is diazepam, flurazepam, nitrozepam, alprazolam, temazepam, triazolam, etc. The second subclass of benzodiazepine derivatives are anxiolytic agent, or the drug used in anxiety. Example of this class of drug includes diazepam, chlordiazepoxide, oxazepam, lorazepam, and alprazolam. The third subclass of benzodiazepines is anticonvulsant, or the drug used to treat the convulsion or epilepsy. The example of anticonvulsant are diazepam, lorazepam, clonazepam, and the clobazepam. The next class of sedative hypnotics include amides and imides. The example of amides and imides is glutithamide. Fourth class of sedative hypnotics are alcohol and their carbamate derivative. The example of alcohols is ethylchlorovinol. Carbamate derivative include the meprobamate, chlorphenicin carbamate, and methcarbamol. These are the carbamate derivative. Fifth and last class of sedative hypnotics are aldehyde and their derivatives. The example of aldehyde and their derivatives are, first example is a chloral hydrate, then trichlorophosphodium, and the third drug comes under this class is aldehyde and is paraldehyde. It's a aldehyde derivative. In this part, in this lecture, we are going to cover the first class of a drug, that is barbituric acid derivative, and the rest of the class of sedative hypnotics we will see in the next lecture and the part second of this hypnotic and sedative. So let us start with the first class, that is a barbituric acid derivative. As we know that barbiturates are classified according to their duration of action, that is a long, short, and ultra short. We will see the mechanism of action of a barbituric acid derivative or barbiturates. Barbiturates binds to a specific GABA A receptor subunit at a central nervous system neuronal synapse, and which facilitate GABA mediated chlorine ion channel opening. All of you know that the GABA is the ion channel receptor. Which type of ion? Chlorine ion. Due to increase in intracellular chlorine concentration, there is an enhanced membrane hyperpolarization. And all of you know that the GABA receptor are inhibitory in nature. GABA receptor is the ion channel receptor. It's an inhibitory receptor. So this barbiturates acts on this GABA A receptor subunit and shows its action as a sedative and hypnotics. If you look out the diagram of this GABA receptor on the slide, you can easily find that the GABA receptor is an ion channel receptor. It's a chlorine gated ion channel receptor. This receptor is made up of 2 alpha units, 2 beta units, and 1 gamma units. These are the polypeptide units: 2 alpha, 2 beta, and gamma. If you look out this receptor very peacefully, then you can see that barbiturates acts or binds at alpha and beta subunit. GABA, that is gamma aminobutyric acid, binds at beta unit. Diazepam antagonist, that is a flumazenil, are binding at alpha and gamma site. If you look out the another view of this GABA receptor on next slide, you can easily find the cell membrane, then 2 alpha units, 2 beta units, and gamma units. You can easily find the barbiturate binding site, GABA binding site, benzodiazepine binding site, flumazenil binding site, zolpidem binding site. In this way, these barbituric acid derivatives binds to the GABA receptor and shows its sedative and hypnotic action via this ion channel receptor. Next part of this lecture is structure activity relationship of barbiturates or barbituric acid derivative. If you look the slide, you can find the structure of barbiturates or barbital. The barbituric acid derivative is 2 nitrogen atoms, 6 member ring, pyrimidine 2,4,6 trione. Pyrimidine 2,4,6 trione is nothing but a barbituric acid. The first point in a SAR is the both hydrogen atom at a 5 position. Look out the 5 position in the structure. Both hydrogen atom at the 5 position of a barbituric acid must be replaced. It's a very important thing. It must be replaced. Why? The reasons are: the first is a tautomerization to highly acidic trihydropyrimidine at approximately pKa 4 can occur. Because of this, the compound is largely in ionic form at a physiological pH, and because of this, the little non-ionic lipid soluble compound is available to cross the BBB, that is a blood-brain barrier. Because of these 3 regions, the 5 position 2 hydrogen atom in a barbituric acid is replaced, and you can see all the derivatives where the 5 position hydrogen is replaced with alkyl groups. This is the first point of a SAR. Next point of a SAR is 5 position lower alkyl. If the 5 position is substituted with lower alkyl, there is an increased onset in hydrophobic carbon content. If the carbon content is hydrophobic, then there is increase in onset with lower substitution at 5 position. 5 position is in inverse correlation between the total number of carbon and duration of action. Inverse proportion correlation means total number of carbon increase, duration of action is decrease. Total number of carbon decrease, duration of action is increase. In this fashion, this substitution will act. Barbiturates are acts sedative they are also act as a hypnotic, they are also act as an anesthetic, and they are also act as an anticonvulsant agent. Next point in the structure activity relationship, to obtain optimal therapeutic results, the substitute radical on carbon 5 should contain minimum 4. How many? Minimum 4 and maximum 9 carbon. Addition of more carbon lead to convulsion activity. Means you should be limited within a carbon 4, minimum 4 and maximum 9 at 5 position. If you increase, then the activity changes. The drugs are convulsant. It produces the convulsions. Unsaturated. Next point: unsaturated carbon chain are more readily oxidized and hence are short acting. So the unsaturated carbon chain are more readily oxidized and hence the short acting. The next point in a SAR, structure activity relationship of a barbiturate, short chain are more stable, hence are long acting. So if you look at the structure of all long acting barbiturates, they have short chain. Long chain are easily oxidized and hence short acting. If you look out the short acting barbiturates, they have long chain, and because of this long chain they oxidize. That's why they are unstable, and that's why they are short acting. It's very simple. Branch chain tend to be a shorter in action than the straight chain. Branching and straight chain. This is the difference between the branch chain and straight chain as a structure activity point of concern. Next point: only one aryl radical should be attached to carbon number 5. Again, the point is related to the substitution at a 5 position. Next point in the structure activity relationship of barbiturates, replacement of oxygen atom on carbon number 2. The nitrogen have a 1, carbonyl have a 2, carbonyl carbon have a 2 position. This carbonyl carbon is replaced by sulfur atom, and because of this there is an increase in potency and instability, and additionally shortening the duration of action of the compound. The barbiturates containing the oxygen in carbon 2 are called as oxybarbital. So in above structure there is oxybarbital. If this oxygen is replaced with the sulfur, then these barbiturates are called as a thiobarbiturate. Next point in a structure activity relationship, attachment of alkyl group to one of the nitrogen atom. If you recall the structure of barbiturates, so nitrogen is present at a 1 and 3 position. So if the attachment of alkyl group to one of the nitrogen atom, position 1 and 3, increase the anesthetic potency and tends to stimulate the CNS, central nervous system. Substitution in both the nitrogen atom produce the convulsion. If both nitrogen are substituted, then the convulsion may produce. Replacement, next point in the structure activity relationship, replacement of oxygen on carbon 2 by an NH group destroy the hypnotic activity of molecule. Destroy the hypnotic activity of the molecule. Next slide will give you a feel about the structure of barbiturate derivatives. We will see one by one. The first barbituric acid derivative or the barbiturate is the mephobarbital. If you see the structure of mephobarbital, it's 5 position hydrogen, both hydrogen replaced. The one hydrogen is replaced with ethyl and second is replaced with a methyl. But additionally, the mepho, Me, stand for the substitution of a methyl at a 3 number of nitrogen atom. Look at the structure of a mephobarbital. The nitrogen 3 substituted with the methyl, 5 position, 1 hydrogen replaced with ethyl, and next hydrogen is replaced with a phenyl. The next structure is a phenobarbital. The phenobarbital and mephobarbital are same structure. The only difference is the methyl group at a 3 number nitrogen is absent in a phenobarbital. That is the only structure difference between the phenobarbital and the mephobarbital and a phenobarbital. We will move to the next barbiturate derivative is the amobarbital. Amobarbital is the 5-ethyl 5-isopentyl 2,4,6 trione pyrimidine 2,4,6 trione. Pyrimidine 2,4,6 trione is nothing but a barbitol or barbituric acid derivative is the amobarbitol. Then next is the butobarbitol. Butobarbitol, where the 5 position is substitutions are 5 secondary butyl and 5 ethyl, and the basic nucleus, that is a pyrimidine 2,4,6 trione, is again same. We will move to the next barbiturate derivatives. Next barbiturate derivative is a pentobarbitol. Where the pentobarbitol in structure of, look out the structure of pentobarbitol, where the 5 position hydrogen is replaced with ethyl, and second hydrogen of a 5 position is replaced with a pentane 2-yle. 2-yle means the pentane 5 carbon chain were attached to the pyrimidine 2,4,6 trione at a second position. Look the substitution of a pentane. It attached to the second position. That's why the pentane 2-yle pyrimidine 2,4,6 trione. So 5 ethyl, 5 pentane, 2-yle pyrimidine 2,4,6 trione is nothing but a pentobarbitol. Next drug is a secobarbitol. The structural difference between a pentobarbitol and a secobarbitol is only the 5-ethyl is replaced with a 5-allyl. 5-allyl, allyl is a CH2 double bond CH2. It's a allyl. All of you know that these two very famous functional group, allyl and vinyl. So here is the allyl. Allyl is nothing but CH2 double bond CH2. So 5-allyl replace the ethyl in a pentobarbital, you will get the structure of a secobarbitol. So these are the very famous barbiturate drugs. Then we will move to the next part, that is the action of a barbiturate. Barbiturate depress the CNS. At low dose, the barbiturate produce sedation. Sedation means it shows the calming effect. It reduces the excitation. It reduces the anxiety. It reduces the worry. It reduces the tension. Second action of a barbiturate is on respiratory tract. It depresses the respiratory system. Barbiturate suppress the hypoxic and chemoreceptor response to carbon dioxide, and overdose is followed by respiratory depression and death may occur. The next action of barbiturates, barbiturate is enzyme inducer. Barbiturate which induce all cytochrome enzyme, all microsomal cytochrome enzyme in the liver. That's why this barbiturate shows the number of interaction with a lot of drug because of this property or this action, that is enzyme induction. If you look at the pharmacokinetic of barbiturates, all barbiturates are redistributed in the body. Second pharmacokinetic property of barbiturates, barbiturates are metabolized in liver and inactive metabolites are excreted in urine. They readily cross the placenta and can depress the fetus. That's why it is administered very cautiously in pregnant women. Toxicity, extension of CNS depression affects dependence liability. It's more as compared to the benzodiazepines. Interactions. In interaction, additive CNS depression with ethanol, it shows the additive effect with ethanol, and many other drug, induction of hepatic drugs, drug metabolism enzymes. After the action, we will see the therapeutic uses of barbiturates. The first is anesthesia. In that, selection of barbiturates is strongly influenced by the desired duration of action. The ultra short acting barbiturates such as thiopental are used as intravenous to induce anesthesia. These ultra short acting barbiturates are used as induced anesthetic agents. These drugs are also used to treat the anxiety. Barbiturates have been used as a mild sedative to relieve the anxiety. As I say, it is used to reduce the tension. It is used to reduce the worry. It is used to produce sleep in insomnia patient. There is a loss of sleep because of tension and worry in that patient. Those patients who are unable to get sleep properly, the barbiturates are administered to get good quality of sleep. When used as hypnotics, they suppress rapid eye movement sleep, REM sleep, more than other stages. However, most have been replaced by the benzodiazepine class of drugs. These barbiturates are also used as an anticonvulsant, used in a convulsions. Phenobarbital is used in long-term management of a tonic-clonic seizure. also used in status epilepticus and eclampsia. Phenobarbital has been regarded as the drug of choice for the treatment of young children with recurrent febrile seizures. However, phenobarbital can depress the cognitive performance, that is related to the memory cognitive performance in the children. That's why this drug are very administered very cautiously in the children, because it's affect the cognitive function of the children. Phenobarbital has a specific anticonvulsant activity that is distinguished from the non-hepatic CNS depression. At the end of this presentation or today's lecture, we will see the adverse effect. These barbiturates causes addiction. This may causes drowsiness, it produces nausea, it causes vertigo, it produces tremors, and as we discussed, these drugs are enzyme inducer. So these are the some adverse effect of barbiturates. So we will see the rest of the drug, that is a benzodiazepine class and other class in a part second. So if you have the queries related to the part first, if you have any query or problem, or if you are unable to understand any part of a barbituric acid derivative as a hypnotic and sedative, you can free to ask me, free to mail me, free to WhatsApp me. So I will clear your doubt as my level best. Thank you for listening this lecture. Share your ideas, your views, your queries on my email ID, or send me a WhatsApp. I will try to solve the queries. Thank you all.